Welcome back to IM1, everybody. Today's topic, 3.2.2, how can rectangles help me multiply? And the learning target for today I'll be able to use algebra tiles and area models to represent expressions and multiplications. All right, so sweet question 383, write a simplified expression for the area and for the perimeter using the figure, right? So what we want to do here is, again, first let's figure out the area, which, remember, it's pretty much just adding all the interior parts, right? How much carpet do I need to cover each of these rooms, right? And then the value inside of each of these gives us pretty much the area, right? And then this should be X and these two should be 1. So if we add up all those together, we get that the area is, we have Y plus Y, which is 2Y. And then we have 2X's plus 2X, and then plus 2 at the bottom, right? And then our big rectangle right there in the middle, which is just XY. Now the order for these shouldn't really matter, so because you're adding, so the order doesn't matter when you're adding, okay? So that's the area. Now let's look at the perimeter. And as we discussed yesterday, the perimeter is just the exterior part, right? So here, this side for this is Y. This top part is 1. This is X right here, right? X times Y gives us XY. And then this would also be 1. This side would also be Y. These two at the bottom right here would also be 1s on each side. And then here is 1. Here's another 1. 1 unit, 1 unit. And then this plus this would be technically just X. And then these right here on the side are 1 as well. All right. So now we look at the perimeter. So we add everything up together. So we have Y plus 1 plus X plus 1. So Y plus X plus 1 plus 1. All right, so we got those, and then Y plus 1 plus 1. So that's 2, 3, and then 4 with the green one, 5, 6, 7, 8. So plus 8. And then we have one more X right there, plus X. And if we put all those together, combine the like terms, and then we have these as well. So the perimeter would be equal to 2X plus 2Y plus 10. And that's pretty much our area and our perimeter. Now let's look at problem 384, which is pretty much kind of the same thing, right? You've seen that the area of the rectangle can be written as different ways, right? As a product of the width and the length, and as a sum of the area of its parts, right? So again, the rectangle can be represented as the area can be represented as 2 ways, right? Like, let's say we have a small rectangle like this side is 8, and then the height is 6. So we know the area is just 8 times 6, which is 48, right? So again, the product, which is these two, is still 48, and that's still equal to 48. So that's pretty much the two different ways, right? The length times the width is equal to the total area. So now we're going to look at pretty much the next part. We're using the algebra now. So write the area of the following rectangle as a product of its dimensions equivalent to the area as the sum of its parts. So first, let's figure out the exterior part. What is the length? And then times the width. All right, and then we're going to equal it to the sum of the interior parts. All right, so the length, let's figure that out. So this is Y, and then this with this one's X, this one's 1, this one's 1. So we would say Y plus X plus 2. And then the width times the width, which would be this. We have our height for this first rectangle right here is X, and then all these are 1s. So that would give us 4, X plus 4. And now we're going to add up all the interior parts. So let's start off with so we have just one xy. So xy. And then we have 1, 2, 3, 4. 1, 2, 3, 4 y's. And then these over here are all x's. So plus 4y. And then these would be 1, 2, 3, 4, 5, 6 x's. And then we have a total of 8 unit tiles, so plus 8. So that's exactly the pretty much both the length times the width. So if we multiply this, it should always give us the sum of the interior parts. Question 385, write the area of the following rectangle as a product of the dimensions equivalent to the area of the sum of its parts. So we're doing exactly the same thing now. So again, let's try it. So the length times the width, and then again, the sum of the interior parts. So let's first find the base of this, right? The length. So x, 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 all these are ones. So that gives us 4x plus 5. And then the width is x, and then plus x, and these are ones as well. So that would be 2x plus 3. And then we're going to add up all the interior part, all the inside. So we have 1, this should also, these are all x squareds, right? And the long rectangles that we have in here, they're all x's, right? So we have a total of 3 here, 3, so that's 12. And then over here we have 5, 10. So we have 22 of those in total. So 22x. And then we have 8x squared. So 28x squared plus 22x. And then we have 15 units, right? So plus the 15 unit tiles. Okay, and then let's look at the last problem right there, 386. Now this should be a lot easier because now we're using numbers instead of just having to count tiles, right? So it says, how is it similar to the algebra tiles in problem 385? And then how is it different? So here, how is it similar? If you guys notice, you're using the area model, right? This is pretty much area. So instead of me writing out 12 of the long of these, right? I just write the number 12x. It makes it a lot easier. Instead of me drawing 15 little square units here, I can just write the number 15. You see what I'm talking about? And then instead of me having to write, like draw 8x squares or 8 squares that have the area 8x squared, I can just use the number. So again, those are the similarities, right? And if you notice, pretty much the 12x is also on top. The 15s are also around the same spot. The 10 is also in the same spot. So it's kind of mirroring almost the same thing, right? It's almost exactly the as the previous if we're using the algebra tiles. So here, if you notice, we can still write it. So we have the length, our width was 2x plus 3. And then our length is 4x plus 5. So that still remains the same, right? And then again, if we were to multiply these, 2 times 4x, we would get 8x squared. 3 times 4x gives us 12x. 3 times 5 gives us 15. And then 2x times 5 gives us 10x. So, and again, if you guys combine the like terms in here, which would be just those two, we get 8x squared plus 22x plus 15, which is exactly the same thing we got right there.